Okay, we're going to look at building graph models ourselves now, and these problems you can find in the textbook on pages 193 and 194. Pages 193 and 194. We're not going to do too many. We're only going to do a couple problems here. So it shouldn't take very long, but it's really, this is all about being able to build a graph that models a situation. So number 17 here, figure 5-34 shows a map, downtown area of a city, and a river going through the city, and it has 3 islands in the middle of the river, and they're all connected to the land, both banks, by bridges. What we're going to do is we want to draw a graph that models the layout of Kingsburg. So a couple things to think about before we start here is that when you are building a graph, so to build a graph, you need to think of a couple of different things. Number one, I think the easiest way is, what are the connector pieces? Okay, think about what are the connector pieces, and then after you know what the connector pieces are, what are they connecting? Okay, so when you figure out what the connector pieces are, these will usually be the edges of our graph. And then the things that they are connecting will usually be the vertices. Okay, so if we come over here to our map, we notice that the pieces that are connectors are the bridges, right? So a couple bridges here, there's a bridge there, a couple bridges like this. So those are the parts that are connecting things. So what are they connecting? Well, they're connecting the land masses, right? So we have these land masses that are being connected. So to build a graph, it's really just as simple as that. So what we want to do is we want to first identify how many vertices we're going to have. So the vertices, those are the things that are being connected, and those are the land masses. So how many of those do we have? Well, we have 1, 2, 3, 4, and 5 land masses. So to start building this graph, there's 1, 2, 3, 4, 5. So this is the north shore up here, North Kingsburg. This is south. This is landmass A, landmass B in the middle, and landmass C at the end. Okay. Now all we have to do is draw in the bridges. So from the north to landmass B, I see that there are 2 bridges. So I'm going to have a double edge. And then connecting B to A, there's 1 bridge. Connecting B to C, there's 1 bridge. I also notice that there's a bridge going from the north to landmass C, so we need to connect that one. And I notice now from landmass A, we go to the south, and from landmass C, island C in the middle, we go to the south. So there you go. That's all there is to it. There's our first graph. And it's really just about being able to figure out what are the connecting pieces and what are the things that we want to connect. So moving on, let's go down here to problem number 19. This one might be a little bit tougher. A night watchman must walk the streets of the Green Hills subdivision shown in this figure. The night watchman needs to walk only once along each block. Draw a graph that models that situation. So what are the things that are being connected? Well, the things that are being connected are the intersections. So there's a 1, 2, 3, 4, 5, 6, 7 intersections along the top. So we can start with those 7 vertices. Okay, there are 1, 2, 3, 4 intersections down the side. So 1, 2, 3, 4 down the side. And then I notice this second row just mirrors the top row, so we can go right across. Perfect. This third row is a little bit different, so I'm going to make it a different color. Notice coming in from the side, we only have 1, 2, 3, 4. So coming in from the side, 1, 2, 3, 4. Okay, this next row down, we'll go back to red. We have this one. It only comes over 1, and then there's nothing else in that row until we move over. Well, how many are we skipping? Well, if we look at the top, we're skipping 1 in the middle, and then we're coming back over. So I'm skipping 1 in the middle and continuing, and then it just goes all the way, like so. And then on the bottom, the very last one down here, I see that I have this one that comes in, and then it skips a block for the park, right? It skips an intersection and goes to the next one, and then there are 3 more. So I've laid out the vertices. Now it's just a matter of drawing in the edges to connect them. So if we come back up to the top, notice each one of these vertices are connected by one edge right across the top. There it is. And then coming down the side here, these are all connected. The next one is all connected here. So like that, right? Next one. Now we're on the third row, right? We're on this third row. We're going to come across and across and across and across. And notice this right here, this vertex, is this T intersection at the edge of the park. So then this one goes up and it comes down. Okay, now we're coming to this one. We come across. There's another T intersection that goes up and down. And then on the bottom, it just goes straight across. Right? And then we have the streets going north and south. So those will be connected with edges like this. Notice we have the park in the middle there, and then we have these edges. So there's a pretty good graphical representation. Notice that I have a park, the first park here, and the second park here. Perfect. Okay, our next graph, and the final one we're going to do today, is a tournament graph. So here we have 6 teams, A, B, C, D, E, and F, and they're entered into a softball tournament. The top 2 seeded teams, A and B, only have to play 3 games. The other teams have to play 4 each. The tournament pairings are, and this just tells you who plays who. So this is really, if you think about it, each edge is going to be a game, and the game is connecting the teams, right? So the teams are what need to be connected. So those are my vertices. So there's A, B, C, D, E, and F. So A, B, C, D, E, and F. And there they are. So who's playing who? So A plays against C, E, and F. So A is going to play against C, E, and F. B plays against C, D, and F. So B plays against C, D, and F. C plays against every team except F. So C is going to play every team. So they're already playing A. They're already playing B. They're going to play D. And they're going to play E, but they're not going to play F. And then we have D plays against every team except A. So D is going to connect to everybody. D to B, D to C, D to E, and D to F, but not A. And then we have finally, we have here E plays against every team except B. E plays against every team, so D, A, C, and F, but not B. And F plays against every team except C. So does F connect to every other team? Well, if you think about it, there are 4 other teams left. So let's make sure that the degree of F is 4. 1, 2, 3, 4. Perfect. So there's a graph that represents these tournament pairings. So really, building graphs is not terribly difficult. What you'll find is you might want to start by just labeling the vertices and put them kind of around a circle if you can. And then if you feel like you need to clean the graph up, you can always redo it and move the vertices.